So I repeat, sorry. I'm Dora Blanco. I'm going to present chapter 5 of this subject. And it's important that you should deliver some assignments around December. I will say exactly the date. The assignments will be described in this presentation. This is a PDF file that will be available using Aula Cesga or in Teams, directly in Teams in the files section of the subject. Well, we'll have 5 hours, 2 hours today and 3 hours next week devoted to the subject. And I'm going to explain you the content of these hours of these classes and of the assignments. First of all, the assignments of this chapter correspond to a small part of the final grade of the subject because it's only 5 hours and should be solved in groups of 2 students. So please contact one of your colleagues in the subject and tell me in the group, because it's necessary that I know the composition of the student groups in order to tell you the assignments that you should deliver. Tell me the composition of the group before November 12, next Friday, if I'm correct. In case you pass the assignment of the chapter last year, please contact me using Teams, because it's possible that you don't need to repeat the assignments in case you did it last year and you passed them last year. The language for the assignments can be either English, Spanish, or Galician, and you have to deliver only one PDF file for each group of 2 students. In case you are alone or you are living or attending from any place that makes you difficult to work in a group, tell me, and you can work alone in the group. The deadline for the assignments is December 7th. Well, the assignments are only some exercises. Exercise 1 is on the evolution of the interconnection networks. In this chapter, we will talk about different features of the interconnection networks. These are very relevant elements in the architecture and not usually studied during the usual grades. Because studying interconnection networks requires to talk about the role of the operating system, the role of the topology, of the routing algorithms, of the switching algorithms, and many other details that are necessary in order to know the interconnection networks in detail. In this chapter, we talk about all these topics, and the exercises try to evaluate some of these topics over some of the systems that we have available, and solving small exercises. In this case, exercise 1 is on the evolution of the interconnection networks during the last 10 years. During the last 10 years, many important changes have happened in the interconnection networks. Mainly, the tendency or the trend is towards systems that are mainly clusters. The more powerful machines, computing machines, are usually clusters or MPPs, and in these machines, InfiniBand is usually used in the case of clusters, but we have many other networks, for example, custom networks in the case of Fugaku or other relevant MPPs, and it's very important to know the details of the networks. This first exercise is on the evolution of the top 500 list over the last 10 years. What are the most relevant changes in the last 10 years regarding interconnection networks? What is the most common interconnect system in the latest available list? What is the interconnect that provided the maximum aggregated performance during the last 10 years? Which is the interconnect that provides the maximum aggregated bandwidth during the last 10 years? All this information can be answered in top500.org, so you can go through the web page and try to find this information. In some cases, some authors wrote papers or reports on the list. So this information is available through many sources, but basically try to answer using the web page of Top 500. The second exercise is based only on the top 5 interconnection networks, the interconnection networks of the top 5 computers. In this case, I will assign to each group 2 of the top 5 systems of the last available top 500 list. The objective is to analyze the interconnection system of these 2 particular systems, explaining the main architectural characteristics. Well, you already know it because in the first chapters of this subject you studied the architecture, but now we are going to focus on the interconnection network of the systems. The more relevant characteristics, the interconnect technology, the topology, and all other features that you can find or in the web page of the supercomputing center associated to the system, or in the top 500 web page, or using papers, reports, or any other information. Please, in case of using any external relevant reference, include a bibliography section in your report. Exercise 30, exercise 3A is an exercise for comparing different topologies for static networks. The topology is the 3D disposition of the nodes of the network. And it's very important. Static networks are the networks whose topology doesn't change a long time. These networks are hypercube, for example, torus, meshes, all these kind of networks. We will study these networks in the chapter. In this case, we are comparing a network with around 50,000 nodes, and comparing the topologies hypercube, 2D torus, and 2D mesh. Exercise 3B is also a comparison of different topologies, but it's a different version of the exercise, comparing hypercube, 2D torus, and a barrel shifter. We will find these topologies along the chapter. In the case of exercise 4A, the comparison is based on analyzing different topology, mixed topologies. In this case, for example, considering a hypercube with a barrel shifter in each one of the nodes. The comparison is based on commenting the advantages and disadvantages of any of these topologies that are in the text of the exercise. A similar exercises 4B, in this case, is necessary to compare an hypercube with node with a 2D torus in each node. In the similar, following a similar structure, answering how many links are required by the network, the degree, diameter, and bisection width of the network. All these characteristics are defined in the chapter, and comment on the advantages and disadvantages of this topology, comparing to only a hypercube for all the nodes or only a 2D torus for all the nodes. Exercise 5A is a comparison of switching algorithms. We will define the switching algorithms. Basically, these algorithms trying to answer to the question and how the route between one node in a network and another node in the network is used for the different packets of the network. In this case, 5A, the comparison is for wormhole switching algorithm and store and forward switching algorithm. These algorithms are described in chapter 5.2. In the case of 5B, we explain that we have a number of nodes in a 2D torus topology, in this case 1024 nodes, and we give some constants that are necessary to calculate the time necessary to send one message from one node to another node of the topology. And it's necessary to make simple calculations for comparing the switching algorithm in the case of cut and through switching algorithm and store and forward switching algorithm. Well, these are all the assignments that is necessary to deliver. Remember the information that it's at the beginning. It's necessary that you tell me the composition of the group, of the two-person group, using a private message using Teams to me, to Dora, before the next Friday. And it's necessary, then I will publish a list of exercises for each one of the groups. Not all the students need to solve all the exercises. I will select different exercises for the different groups, the same number of exercises for everybody. And there is a deadline, December 7th, to deliver the PDF file using a task that will be created. I will create the task for deliver the exercises in Aula CESGA. Only one PDF with all the solutions for each pair of students. Well, once all this information regarding the evaluation of the chapter has been explained, I'm going to explain the content of the chapter. First of all, this is all the tasks that you need to solve for this chapter. So we don't have exam, neither other type of evaluation, unless you fail the evaluation of the tasks. Well, now I'm going to explain about the chapter. The chapter is divided. I have divided the chapter in two parts, one part for this week and another part for the next week. I'm going to explain you the different parts of the chapter. As the contents are theoretical, all the contents, I'm going to share with you in English now an scheme of the chapter and the bibliographic references. Then I will upload videos for the content corresponding to this session. The videos for this week are one video that lasts approximately 1 hour and one video of 24 minutes. More than required for this week, but it's the best part, it's the best way of dividing the subject. So I will upload the videos to the files section in Teams, and you can see the videos at the speed that you consider adequate. In the videos, I explain all the contents of the chapter. In case you need help from my side, I will be here until 8 today when I finish, and obviously next week at 4 in the afternoon. Next week we will have 3 hours, so I will contact again next week at 4, and I will explain some examples of networks in relevant computers, some characteristics of the networks, and will upload the videos corresponding to the next week. I think that this is the best way of taking profit of your time. Only one moment, because I need to open a new file. Some of you have already written your groups. Thank you. You can write the composition of your groups when you consider adequate. And I'm going to open another document. You can see in the Archivos section of Teams, you can see a folder called Chapter 5, and inside the folder, the document with the HPA assignments and the PDF file corresponding to the first part of the class. Only one moment, please, because I have to go there to share with you. You can see HPA assignments, Chapter 5, the explanation of the exercises. Remember that you don't have to solve all the exercises. And HPA Chapter 5, Part 1, the PDF file that will be explained in 2 videos that I will upload in some minutes. I'm going to open one of the documents to explain you some relevant details. Please tell me in case you have any comments or any comment or anything that you want to share with me, or open the microphone without problem. This is a this is very theoretical chapter, so the exercises are mainly related to topology, switching algorithms. I'm going to share again this document to explain you some details of the chapter. Well, the PDF file that I have uploaded to Aula CESGA and to Teams is this document, Interconnection Networks Part 1. And in this part, I explain parts of the Interconnection Network chapter. This chapter is organized first in an introduction, including a network classification. Then some basic components of a network are explained, the links, the routers, the network interfaces, and their properties, the main elements that are available in a network. Then I explain some performance parameters, how to evaluate the quality of a network, the performance of a network, divisibility, availability, bandwidth, different characteristics. It depends obviously on the system and on the machine. The parameters that are more relevant for one system are not so relevant for another system. In the case of the design of the interconnection networks, I explain topology, the 3D ubication or organization of the nodes of a network, switching techniques, routing techniques, and flow control, and the situation of logging. Generally, well, I'm going to explain some details now. Finally, I talk about some interconnection trends. All the information required to solve the exercise is in this part and the part of the next week. In this case, all the chapter can be followed using different books. There is no preference source, because all this information was done or was established for me using different books, reports, web pages. But basically, here we have some books that talk about interconnection networks that can be useful for you. First of all, the book Computer Architecture by Hennessy Patterson. It's a very relevant book in computer architecture, and in particular, Appendix F of this edition is all about interconnection networks. There is a Spanish book, Arquitectura de Computadores, from Julio Ortega, Maciangit, Alberto Prieto. It's a classical book on computer architecture. Principles and Practices of Interconnection Networks is also a very relevant book, but with many details, very deeply explained. So it's a little bit hard to understand in some parts, but it's very relevant. And finally, I mentioned interconnection networks and engineering approach. Part of the slides of this chapter are based on figures from these two authors, Duato and Jamalinchili. These are very relevant researchers, especially Duato is a professor from Universidad Politécnica de Valencia. He's a very relevant person, and in the field of research in interconnection networks. All these books are very interesting. And you can find reports or information from some companies, from different companies that developed networks that can explain details of these networks. Regarding all this information is explained in detail in the videos, but I want to tell you that basically we have 4 domains for interconnection networks, 4 big types of interconnection networks: OCNs, SANs, LANs, and WANs. OCNs are networks on chip, networks that communicate a small number of elements on a chip. These kind of networks are very relevant in the market today, and are explained here. Networks, for example, AMBA from ERM and other networks that have been designed for connecting chips or multi-chips inside a chip or between chips, connecting tens or until 100 of elements or devices, but connecting elements at a distance of the order of centimeters. In the case of some networks, we have, for example, MiniNet, InfiniBand, Quadrix. All these kind of networks connect elements, a higher number of elements, typically at a distance of the order of tens of meters. In the case of LANs and WANs, the distance is bigger and the performance is lower. In the case of LAN networks, we have different types of Ethernet networks, connect hundreds of devices at a maximum distance or a few kilometers, for example. In the case of WANs, these are the first interconnection networks that arose in the past related to all the telephonical networks. The classification in this graph shows that the number of devices interconnected is very variable depending on the type of network, and the distance of the interconnection typical for each kind of network is also very variable. The price, the cost of the different networks is very different. In general, we try to use SANs or LANs for building the usual machines. But in many cases, if we have if we have a very high performance, for example, a supercomputer, we need to develop a particular a network specifically designed for the machine, and then we talk about custom designs, especially this design for this particular machine. We will talk in the videos. We have information about these these networks. Well, a typical the chip network is a bus only a line and all the machines connected to the line. But this is not very interesting. It's not very practical. The most practical network would be a crossbar, all the elements connected to all the elements. For example, I don't remember where is my figure of the crossbar, but basically a bus is only a line and a crossbar is a connection of all the elements with all the elements. It's very expensive because it requires many links, but it's very useful. So the real solutions are in the middle of the bus and the crossbar, trying to find an equilibrium between performance and cost of the network. In the structure of the network, it's very relevant to know that we have different. Sorry, we have the information here. Well, if we have a multiprocessor, in many cases, this is the typical structure. We have an interconnection network uniting the different, making the union of the different elements, processing elements, PA, and in many cases with memory. In the case of multi-computers, each node is a processing element with input, output, and memory. And we have the interconnection network connecting all the elements with using a crossbar, a bidirectional multi-stage network, a fat tree, a torus. It depends on the machine. I want to share with you also that in many cases, when we have a multi-computer, we need in many cases a hardware part of the interconnection network to connect the network with the processing element. This network interface is also explained in this chapter and in the videos. And we will explain how the hardware interface is and the functions carried out by the network interface. Basically prepare and copy and storage the information that is sent through the network. In the case, I also have to go directly to this part to share with you. Well, in this case, we have a figure connecting with a switch, an inner switch. We are connecting different processing elements represented at the end of the lines. And we have a part that is in charge of deciding the route that will be followed by any of the messages that will be sent and are making an arbitration of the hardware available. I also want to share with you information in this, in this slide. Well, one, it's very important that that an interconnection network have to decide when it's necessary to connect two nodes to sending a message from one node to another. It's necessary to decide which of the possible paths are allowable for packets. This process is known as routing. Then it's necessary to decide when the paths are available for the packets. This decision is known as arbitration of the paths. And finally, it's necessary to decide how the paths are allocated. All the path is allocated for a private message, only one part of the path, how these paths are allocated. This is answered by the switching algorithms. So routing, arbitration, and switching are very relevant tasks. And in particular, we have to compare switching algorithms in exercise 5 of the assignments. So it's very important that we go to the part of the chapter related to the switching algorithms and understand perfectly all the explanations there. In this first part of the chapter, we only have a mention of these algorithms because the last part of the chapter is devoted to analyze the performance of the networks based on time and productivity from one side and based on scalability, fault tolerance, quality of service, efficiency from another side. So this first part of the chapter is based on explaining, or is focused on explaining the main characteristics of the networks, how the network interface acts, which are the most relevant tasks performed by the network interface, and how the performance is measured. Next week, we will talk about routing, arbitration, switching, and topology of the networks. So I talk too much. I have explained the main contents of the subject, and I will upload just right now a couple of videos in the section of chapter 5 here in Teams, so you can follow these videos. The videos are in Spanish, but the slides are in English. Are these slides that I commented just right now? In case you have any doubt or any problem, please contact me. In case you have any doubt just right now, I will be here until 8. So the communication will be opened. If you have any comment, just share the comment with me. But I think that it's better that I upload the videos so you can follow them and you can focus only on the part that you consider more interesting for you. And next week at 4 we contact again and continue with the next part of the subject. Then I'm going to stop the recording and just